So this is my model of melanocortin 1 receptor, both the normal and the mutated version. For the model, I used pipe cleaner to mimic the spiral shape of the protein. The little tufts being the spirals that the protein is in. The beads here are amino acids. And then I have the mutation represented with the purple puffball, and the normal model, the red bead, represents the normal Argentine 67 that would be there. So melanocortin 1 receptor has two subunits, eumelanin and phenylalanine. In normal proteins, like up here, eumelanin means that there is a lot of pigmentation, which leads to a darker color. In the mutated protein, there's more phenylalanine, which means there's a lack of pigmentation, which leads to a lighter color. This is all because of a change in the amino acid from Argentine 67 to cysteine 67. Cysteine 67, sorry. Eumelanin will be represented with a red bead because this is normal, so it produces eumelanin. This is cysteine. This is the mutation, so it represents phenylalanine. So in normal MC1R, the presence of Argentine 67 allows the protein to be more active, producing more eumelanin because it can bind to alpha MSH. In the mutation, the replacement of Argentine 67 with cysteine 67 right over here causes the protein to become less active, and it creates an inability to bind to alpha MSH, which is a melanocyte stimulating hormone. The protein switches in the mutation from eumelanin production to phenylalanine production, so a lack of pigmentation shows up in animals and a lighter color will appear. Both the mutated and normal amino acid is located on the inside of the melanocytic cell, just before the cell membrane. So both of them are on the inside of the cell, not in the membrane, not outside of it, but inside the cell. A melanocytic cell is a specialized cell that produces a pigment called melanin, which gives skin and hair its color. So what are some of the flaws of my project? Well, my model is not as complicated as the protein as it is found in the organism. There are 3 rows of amino acids within the cell membrane, but I chose beads to represent bulkiness, and that may not have come across as well. I also did not include a long exaggerated chain of amino acids like in the actual protein. There would be a long chain here and a long chain here without the membrane, or outside of the membrane, and I did not demonstrate that here. There are also nuances within the different amino acids that are present. For example, the ones whose colors I changed only were Argentine and cysteine. I could have coordinated the black beads to the different amino acids that were present within the membrane and throughout the chain, but I didn't. Just to hit home the point that these are the main 2 that have been exchanged. And so the different amino acids that besides Argentine and cysteine are not specified in my model. And yeah, this is my project. So one last look at the normal cell. We have the cell membrane here. And there's amino acids all throughout here. I just chose to represent the ones within the membrane with beads, and it takes on different shapes. And this is the red bead is Argentine 67. And then when we switch over to the mutated, you can clearly see that the Argentine changes into cysteine. This is the big puffball that represents the mutation. So it's still the same structure. The only thing that's changing is the one thing here, the one amino acid here, which is cysteine 67. And this is my project. Thank you.